Hi guys! Now you've probably already seen other videos on SMSL PS200 Pro. Everyone makes silly faces in miniatures and they all say it measures excellent and even on par with DACs many times the price. So can this $85 digital to analog converter really sound as good as other units that are many times the price? Does it really sound well? And should I be making silly faces too? Let's find out. And before I will talk about some numbers, a word on my test systems. I am always using the best available components to push the units I'm testing to the limits and to make sure that there are no bottlenecks in my chain. No bottlenecks that would affect my review. So bear in mind that every single item in my setup, including cables, was much more expensive. And I'm mentioning that because with the cost south of $100, $85 to be exact, this is a high value component that will probably be placed in systems in chains that are using components with the similar price range. More on that in the summary, but the important thing to remember now is that I was squeezing every last bit of performance of that guy from that guy. So let's talk some specs now. And these indeed look brilliant. Dynamic range is specified as 125 decibels. Signal to noise ratio is also specified as 125 decibels. And as you can see in AP measurements posted on the SMSL portal, these numbers are actually quite a little bit higher, maybe not quite high, but a little bit higher. It's just a little bit over 125 decibels in both cases. Now, the total harmonic distortion plus noise, so THD plus noise, is just incredibly low with 0.0009%. That's 4 zeros after the comma. And that number really belongs to really expensive digital to analog converters. Now, this DAC is able to accept anything up to 32 bits and 768 kilohertz and up to DSD 512. That's all thanks to the XMOS 316 USB controller that's found inside. And since we're talking about the inside, let's talk about the build. In front of the device, you have a set of very small LED diodes indicating the currently selected input and also MQA decoding or DSD decoding. This button doubles as a power on and power off switch and also works as a control for selecting the inputs. Now, in the back of the device, we can see that this is a very simple, very focused device because it has USB input, it has a switch that allows you to select, to choose between UAC1 and UAC2 mode for the USB input, basically meaning that with UAC1 you'll have the compatibility with gaming consoles, but your input signal will be limited to, as far as I remember, 96 kilohertz and 24 bits, something like that. In UAC2, you have no such limit, and you can use ASIO driver to use the DAC to full extent. Now, you also have optical and coaxial inputs in SPDIF format, and you have one set of RCA outputs. Now, in order to disassemble the device, you just need to remove the two very small screws that are found on the sides and just pull the PCB out. Now, what can we see here? Let me get my pointer. Super advanced pointer, by the way. Yeah, the first thing that we'll see is XMOS controller here. We will see also ESS Saber digital to analog converter here. And we will also see OPA 1612 operational amplifiers. These are those four guys. Those are probably IV conversion stage, meaning current to voltage conversion. And this one is probably for low pass filter. I have no idea what this one does because the place for that operational amplifier here is not very typical. If you have any idea about that, give me a shout in the comments. I'm pretty sure about those three guys. IV conversion, low pass filtering. And we also have a small IC here that probably works as a buffer or as a switch, allowing the output from the device to passing the output from the device to RCAs. Okay, we also have a couple of ICs that had been sanded down, those guys. So I have no idea what are they doing and what are those. Yeah, they've been properly sanded down and nothing remained from the original markings. And what else? Not much, right? It's a very simple device. Yeah, we can see switch here, we can see LEDs on the board here. Nothing on the other side. Yeah, we can also see two clocks. Where is my pointer? One here and the one here. Yeah, the one of them is for 27 kilohertz. Megahertz, and the second one is for 24.576 megahertz. Yeah. So that's basically it. Very simple, very focused build. It doesn't do much, but it does just a couple of things. Okay, so give me a second to put that back in. Okay, so it's here. Let's connect simple power source, because basically this unit is powered and controlled by USB with this single connection, meaning that you do not need any kind of external power supply if you're connecting this using USB. Okay, so let's power it off. And let's power it on. Okay, so I've chosen USB as an input right now, and let's move it away. I can switch that, clicking here, to other inputs and cycle through them. For a reason that I do not fully understand, because I haven't seen that mentioned in the manual, when I'm choosing USB, DSD is always lit up in green, and not only in this particular situation when I'm using this connected just to the power bank, but also when I was doing my listening tests. When I was using ASIO driver that was forcing specific bit rate and specific bit depth, still DSD was always light up, even if the stream was just PCM. Yeah, so the functionality is very simple, just a couple of things you can do here, not much. So let's talk about the sound quality. One of the biggest questions, does it actually sound good? Let's start with the bass. I know this is irrational, but I felt like something this small will not have a deep bass. I was wrong, of course. This is DAC and not a speaker, and we do have a very competent, deep and clear bass here. It's quite clean with full mid bass that seems to be slightly warm, but just a little, not too much. I'm happy to report that mid bass is kept in check and controlled so it doesn't pollute the mids. Yeah.